Well, we've been looking at derivatives of sine and cos, antiderivatives of sine and cos. Let's have a look at the derivative of tan x. Now, tan x is sine x over cos x. And this is u over v. Now, if u is sine x, then u dash, the derivative of sine x, is cos x. If v in the denominator is cos x, then the derivative of v is negative sine x. And we use the product rule, which is the quotient rule, which is v u dash minus u b dash over v squared. So substitute, v is cos x. U dash is cos x minus u is sine x and v dash is negative sine x, so that becomes plus sine x all over v squared. V squared is cos squared x. Now on the top we've got cos squared x plus sine squared x, cos squared x plus sine squared x over cos squared x. Now cos squared x plus sine squared x equals 1, and 1 over cos squared x. Now 1 over cos is sec, therefore that equals sec squared x. Now actually, you are permitted to go directly from y equals tan x directly to sec squared x as the derivative y dash, because it is on the formula sheet. Like the derivative of sine x is cos x, the derivative of cos x is negative sine x, and the derivative of tan x is sec squared x. So you can actually go straight to it. If you have a question, what's the derivative of tan x? If they don't specify, use the quotient rule. You can straight up say, all right, dy dx or y dash equals sec squared x. You can go straight to that answer because it's also on the formula sheet. So if the derivative of tan x is sec squared x, if your function is sec squared x, what is the primitive of sec squared x? So what is the primitive of sec squared x? Yes, it's simply tan x plus c. So if you have an equation which says the function of x equals sine 3x plus 4 sec squared 2x, well, if you want the primitive of this, the primitive of sine is negative cos. Don't change that. And then divide by the derivative of that, so divide by 3, plus. And the integral or the antiderivative of sec squared is tan, so that would become 4 tan 2x, and divide by the derivative of that, which is 2, plus c. And so you end up with negative 1/3 plus 3x plus 2 and 2x plus c. Cos 3x tan 2x, because 2 cancelled out of the 4. So that's looking at the derivative and antiderivative of tan x and the antiderivative of sec squared x.